1, 2, again 3, again 4. Okay, now so now from 1 to 2 it is connected, again 2 to 4 it is connected, 3 to 4 it is connected, again 1 to 3 it is connected, again 1 to 4 it is connected, again 2 to 3 it is connected. Now tell me how many edges are there, how many vertices are there in this graph. Here in this graph we can say that there are 4 vertices, there are 4 vertices, and how many edges? 6 edges. 4 vertices are there, 6 edges are there here. Okay, let's, if you want it, you can able to try it. E1, E2, E3, E4, E5, E6. So you can see again vertex V1, again vertex V2, vertex V3, again vertex, sorry, wait a minute, I will give according to order itself. V2, again V3, V4. Okay, now so this is basically graph. Okay, so what kind of graph is this? See here, what kind of graph it is? Basically it is a connected graph. Connected graph. Okay, it's connected because all from here, why it is connected? You can ask me, sir, why it is connected, sir? The reason is here from node 1, nothing but vertex 1. I can able to move from 1 to 2, from 2 to 3, again 2 to 4, 1 to 4, 1 to 3, I can able to move. So it is a what kind of graph? Basically, what kind? It is directed or undirected? This is basically undirected graph. One more important thing, it is a undirected graph. Okay, see, if you want to find the minimum cost spanning tree for directed graph, it is not possible. So only for indirect, undirected graph, it is possible. Okay, you should understand this one. Again, now please observe here. Everybody, please observe here. For this graph, I will going to write some of the graphs. You see and observe here. Okay, you see and observe here. Now, first one, 1, 2, again 3, again 4 here. Okay, now see here, 1 to 2, again 2 to 4, 3 to 4, again 1 to 3. Right? Okay, done. See, now also, see edges like E1, E2, E3, again E4. Again, one more edge is there, that is E5. What about E6? What about E6? E6 is not there. Still, please understand, still I can able to connect all the vertices. Yes or not? I can able to connect all the vertices. That is also possible. Hence, I will going to say, I will going to conclude it is also connected. It is also connected graph. So let's take this one as 1. It is also connected graph. It is also connected. Already. Okay. Let's take this one as 2. This is also connected graph. Again, take one more also. Number 3, you take it. 1, 2, 3, again 4. Okay, now here, everybody observe here. With one edge we have removed here, one edge we have removed, still it is connected. If I remove E5 also, can I able to connect? Let's check. Okay, 1, 2, 3, again 4. See, from 1 to 2 I can able to move. From 2 to 3 I cannot able to move, but I can able to move from 2 to 1, 1 to 3. That is also okay. Like that, you can able to see here. Okay, you can able to see still it is a connected graph. Yes or not? Still it is a connected graph. Why? The reason is I can able to move from 1 to 2, 2 to 3, again 2 to 4 like that I can able to move it. Again 2 to 1, 1 to 3 like that I can able to move it. Still it is connected. No problem at all. Okay, that's fine. Not a problem. But it consists a cycle. Yes or not? You see, it consists a cycle. It's okay. It doesn't matter. Okay, again see here. I will tell you why the cycle is important. I don't want to tell right now. Remove this. Later I will discuss. Okay. So still it is a connected. Again connected. Okay. Now again this is also connected. Fine. After that, take fourth diagram. Now see here. 1, 2, again 3, again 4. So what I will do now, I will going to remove. So this is the edge E1, E2, again E3, again this is E4. Okay now. So what I will going to do, I will going to remove the E4 edge here. Like this I will going to make it. Okay. Fine. Now see here. Still everybody observe here. E1, E2, E3. Edges are there, but still it is a connected or not? Still it is a connected because this one is 1 to 2 I can able to go, from 2 to 1 I can able to go, again 1 to 3 I can able to go, 1 to 4. Nothing but I am covering all the edge, all the vertices or not. That is very, very important. I am covering all the vertices or not. That is possible. That's why it is also connected. This is also connected. Fine, understood everyone? Again, see here. Now everybody please observe here. Everybody please observe here. One more diagram. This is the fifth diagram. Okay, 1, 2, 3, again 4. Okay. So now 1 to 2 I will go to 1 to 4 I will going to connect, and 2 to 3 I will going to connect here. Everybody observe here. Can I able to go to 1 to 2? No. Can I able to go 3 to 4? No. But I can able to move from 1 to 4. So basically this, okay, it is not a edge here. It is not a edge here. Actually, I will tell you. Okay, this is not a edge. This is not a connected here. Okay, you cannot go like this. You cannot go like this. Like this. It is not possible. Okay, don't think all those things. Fine. I think you people are okay. So it says that very clearly. I cannot able to move from 1 to 2. I cannot able to move from 1 to 3. I cannot able to move from 2 to 4. But I can able to move from 1 to 4. I can able to move from 2 to 3. That is okay. Nothing but what exactly I am saying here. Very simple. This diagram says that. See here, everybody observe here. This diagram says that it is connected from 1 to 4. Okay. Again from 2 to 3 like this. Like this. See? Is it connected? Really it is connected? No. So that is the reason why it is a disconnected graph. I will write disconnected graph. It is a disconnected one. Okay now. Again, here also you can able to see like this. Okay, no problem. Again, one more diagram I will going to give like this only if you want it. 1, 2, okay. Again 3 here. 3, again 4. See? Now you tell me, is it connected or not? No, it is not a connected one. Why? Because the reason is 1 to 4. Can I able to go? Again 1, 2, 3. Can I able to go? No. That's the reason why disconnected. This is also disconnected graph. Okay, now. So these are the things you need to understand. Okay, now everybody okay? Fine. Again, you can see there are few more things. So what do you mean by cycle? I will go to the next and I will explain. What do you mean by cycle? See here, very simple. Same diagram I will take. Cycle. I am talking about cycle. What is this cycle it is all about? Let's take 1, 2, 3, 4. See here, I will going to connect from 1 to 2, again 1 to 3. Okay, so 2 to 4, 3 to 4. This is called it a cycle. Okay, so all the edges are connected with vertices. Okay, without any gap here. Any gap is there? No gap, nothing is there. So that's why it is called it as cycle. Again, you can create a cycle in different way also, like this. You can able to see it. One more, you take it one more. 1, 2, 3, again 4 here. Like this also you can create. This is also cycle. But what you did? Okay. So, but what you did exactly here? So you missed this vertex. Yes or not? You missed this vertex. Nothing but you are wasting this vertex. Yes or not? You are ignoring this vertex. Nothing but what? You are able to move from 1 to 2, 2 to 3, again 1 to 3. Okay. You are connected with these vertices, but what about 4? It is not connected. That is the reason why it is a disconnected graph as well as having a cycle. It is a disconnected graph, disconnected as well as as well as as well as having cycle. Okay, na? As well as having cycle. It indicates very clearly what it indicates very clearly. If you have a cycle, you cannot create a spanning tree. If you have a cycle, it is not at all possible to create a minimum cost spanning tree. Spanning tree is not possible. Not possible. Okay, na? So this is what exactly I wanted to say with the cycle. If you create a cycle, minimum spanning tree is not possible. Here also you can able to see, it is also connected, but cycle is there. Yes or not? See, if I remove this one, any problem? Let's take E1, let's take E2, again E3. Or still I am able to connect here. Yes or not? 2 to 1, 1 to 1 to 3, again 3 to 4. So that is the minimum thing, but minimum number of edges should be there. That is what we call it as minimum cost spanning tree. Understanding everyone? See, if you don't have cycle, definitely you can able to create a spanning tree. See here, if I remove this, if I connect here, if I connect like this, what happens? It's a spanning tree. Yes or not? Spanning tree, nothing but minimum edges you have to use to connect all the nodes. Connect all the nodes. Suppose think like that. That is what exactly I'm coming here. Suppose think like that. Okay. Suppose think like that. You have 100 computers. That is the reason why we will going to use this. That is the reason why we will going to use this. We have 100 computers. I wanted to connect all the computers. I wanted to connect all the computers. Nothing but minimum. Okay. How many connections are required? You tell me. 100 computers are minimum. How many connections are required to cover all 100? To cover all 100 computers, minimum how many? Okay. Minimum how many connections are there? Minimum connections are required. See here. Minimum connections required are 99. Yes or not? See here. Suppose how many computers are there here? 4. Okay, to connect all the computers, how many required? 3. Like this. If you have 100 computers, minimum connections are required is 99. Yes or not? See here, from 1 to 2. Again, 1 to 3, 3 to 4. Remove this, not required. Remove this, not required. It's a spanning tree. This is what we call it a spanning tree. Okay, that is what exactly I said very clearly about this one. If you have 100 computers, minimum how many required? 99 is required to connect all the computers. That is the reason why this is very, very important when it comes to networks and all. Everything in the computer science is great. Okay. I think you people, this is the concept. Why we are using? The reason is this. The reason is this. Okay, small theory. You can take it. In this, I will give you the definition now. I will give you the definition now. In a given graph, in a given graph, in a given graph, between every two vertices, every two vertices, there is a there is a there is a path. There is a path. Correct or not? There is a path. Then it is connected. It is connected. It is connected. Otherwise disconnected. Otherwise disconnected. That's it. Okay. So please observe here, everybody. Please observe here. In a given graph, So I have taken a lot of graphs, right? So 1, 2, 3, 4. Okay. In a given graph, between every two vertices here. So vertices 1, vertices 2. Every two vertices, there is a path. Yes or no? There is a path. See, there is a path. Then it is called it as a connected. Nothing but you can take like this as well. 1, 2, 2. So there is a path. If there is no path, it is a disconnected. So now there is a path. So that is the reason why it is connected. There is a path between this and 1 and 2. That is the reason why it is connected. If there is no path, think like that, there is no path. Suppose think like that, 1 and 2. So a path is not there. It is nothing but what? Disconnected. Okay. This is the definition I given for connected and disconnected. Clear? Clear? Everybody clear? I think you people got this one. Cycle all those things. Okay. Again, one more thing. Again, say one more thing. Take 1, 1, 2, 3, again 4. Okay. Like this. Okay. This is one more graph. Okay. This is one more graph. Consider. So this is a graph. So I will going to represent this one as G. Okay, this is a graph. I will going to represent this one as G. Again, this graph consists of vertices V. Again, this graph consists of edges. Okay, which are connected. So E. So this is the definition of the graph actually. Okay, this is the definition of graph. Yes, you can able to see same number of vertices of G is there or not? Okay, all the vertices we have to represent. That is what important thing. Again, one more. Take it here. So how to find the spanning tree? For the spanning tree definition now. For the spanning tree definition, a subgraph subgraph a subgraph is of okay, sorry, 1 minute. A subgraph, yes, you take it better. A subgraph S of S graph of the given graph G is equal to V comma E. G of V comma E is said to be spanning tree. Said to be spanning tree if and only if. So how if and only if I will tell you that now. Okay. So there is a graph. This is a graph actually. Okay. That's why G is equal to V comma I. So a subgraph S, you can able to see this is a subgraph S. You can see this is a subgraph S of given graph V comma I. So this is a graph. Okay. In this graph, not a subgraph actually, it's a, okay, just a graph. You take it as just a graph here. G is equal to V comma I is said to be spanning tree. So when you will going to set to be a spanning tree, suppose think like that, what I will going to do, I will going to create a spanning tree for this. For example, I will going to create a spanning tree for this right now. Actually, this is a graph right now. This is a graph. So what I will do now, let's take node 1, nothing but vertex, 2, again 3, again 4 here. So this one I will going to call it as subgraph S. A subgraph S of a given graph. Okay, so there is a graph. In this given graph, I created one subgraph is said to be a spanning tree. If and only if, what are the things we have to satisfy? The first thing is here. What are the things we have to satisfy? We have taken a graph. There is a graph. You see here, everybody. There is a graph. Yes or not? There is a graph here. Okay, so that's why a subgraph of a given graph, nothing but I have to generate a subgraph. This is the subgraph I am generating here. So this is the subgraph I am generating. Given graph G is equal to G of V comma I, nothing but in this I extracted one subgraph is said to be a spanning tree. This one is a spanning tree. How? When? Again, why? We have to say this one. First one. First one, all the vertices must be there in the subgraph. That is what? Nothing but same number of same number of vertices vertices like G, like G. So this is what. So all the vertices must be there. Same number of vertices. Second one. Okay. V minus 1 edges only. V minus edges only. Basically, see, it's a cycle actually. It's a cycle. Yes or no? So that is the reason why V minus 4 edges. Nothing but what is that V minus 1? Suppose think like that. How many vertices are there here? 4 vertices are there. 4. Okay, that is what exactly I'm saying. V minus 1. 4 vertices are there. V minus 1. How many you will going to get it? 3. 3 edges. With 3 edges, this graph is connected. This is what we call it a spanning tree. This is also spanning tree. Without cycle. Without cycle. Again, third one. Important. Okay, no cycle should be there. No cycle. No cycle should be there. No cycle. No cycle. Let me say allowed. No cycle is allowed. Okay, now. So these are the important things you have to take care. These are the important things you have to take care when you are generating the spanning tree. Now let's generate a spanning tree for this particular graph G. So what is that exactly here? See, everybody observe here now. From 2 to 1. Can I connect from 1 to 2? Yes. Okay. Can I connect from 1 to 3? Yes. Okay. Can I connect from 3 to 4? Yes. So this is what we call it as subgraph. Subgraph. Every subgraph of a G is a spanning tree. Okay. Every subgraph of given graph is a spanning tree. Got it, everyone? Got it? So here, simple actually. So how many edges are there actually? Let's take E1, E2, E3, E4, and E5. These are the 5 edges are there. But here, see here, E1, E2, again E3. Here, we haven't connected. That's why removed. So E4 is not there. Again, E5 is not there. Still, we are able to. This condition satisfy or not? V minus 1 edges. V minus 1 edges. Okay, this condition satisfy. I can see here, no cycle. Any cycles is there. But here, see, cycle is there. Okay, all the vertices are there or not? Yes, every vertices are there. So if it is like this, then we can say that it is a spanning tree. For that one also, I will going to write something for you people. Let's see this. Subgraph S, here, if and only if S, okay, S is a spanning tree, S is a spanning tree. S is a spanning tree. Spanning tree of G is nothing but nothing but S is a subgraph of G. Okay, S is a subgraph of G which covers all vertical with minimum edges. Now see everybody, please observe this one, this line. Please observe this line. S is a spanning tree. This one I am talking about. S is a spanning tree of G is nothing but, so we have taken a G. So in this we extracted and we made a spanning tree here. But S is a subgraph of G. Now you tell me, S is a subgraph or not? This is a subgraph now. This is a subgraph. So now that is the reason why we are saying that yes. Okay, this is the subgraph of G, which covers all the vertices with minimum edges. See, am I covering all the vertices? See here, am I covering all the vertices? See, 1 to 2 I am covering, 1 to 3 I am covering, 3 to 4 I am covering without any cycle, Okay, for example, you can take, so see, for this one, I will going to give you a small example. You take it as a startup. Okay, startup. Okay, startup. So what they will going to do, they will going to have only minimum resources. So that is the reason why what they can able to do. So they can able to do the business, but not efficiently, because the reason is they have only minimum resources. But if you go to the big company, they have so many resources, huge resources. If someone goes, they will going to alternate it. They will going to bring back someone else to do that job. So that is the reason why these startups and all going to failure like that. Here you can able to, when you see the subgraph, it having minimum edges to reach all the vertices. But here it's not like that. Some are another way. There will be extra edge. Okay, there will be extra edge. Nothing but more resources are available to reach that particular point. So that is the real beauty of spanning tree. Okay, let's take one example. I will going to take one example and I will wind up. Okay, let's take one example. If possible, I will take examples. Okay, more example. Let's take one more example here. Example 1. I think everybody understood. So why we call it a spanning tree? What is the necessary? All those things. So what we're going to do? Find number of spanning tree number of spanning tree possible for the following graph. So this is the one. Let's take a graph. Now people see it. Let's take a graph. So graph is like this: 1, 2, 3, and 4. Okay, now. So 1 to 2. Okay, fine. Again 3 to 4, like this. Okay. Now see. So this is a graph actually. So what is that? G comma G V comma E. So this is the graph actually. Actual graph is this. If you want it vertices, take it E1, E2, again E3, E4, again E5. Now, how many spanning trees are possible? We have to identify. Just I said right now, what is the spanning tree? So what are the conditions you have to follow though? follow to get a spanning tree. All those things I explained. Now, how many possible spanning trees are possible with this particular graph? I wanted to say. Now see it, everyone. Now everybody observe here. Take first one. First one you take. 1, 2, 3, again 4. Now, so what I will going to do is here like this. I will going to connect like this. I will going to connect like this. I will going to connect. Now you people tell me, is it spanning tree or not? Is it spanning tree or not? Yes or no? So like this, like this. Suppose think like that. I will going to connect this one. So minimum number of edges is there, extra is there. Basically, it's a cycle now. Yes or not? It's a cycle now. So that is the reason why cycle should not be there. I will going to remove the cycle. Cycle should not be there. I will going to remove the cycle. I remove the cycle. See here, I removed the cycle. Now it is connected also. It is a minimum cost spanning tree. Why? So with the minimum edges, I can able to reach all the vertices. I can able to reach all the vertices. Okay, like this. I can able to write like this also, right? You can see here. 1, 2, 3, again 4. Okay, one is over. Here I will going to connect. Okay, again from here I will also connect. Okay, now is it okay? This is A, consider A. This is a B. Okay, with this one diagram, can I able to make 4? With this one diagram, can I able to make it 4? Again turn it. Again turn it this one like this. See what we have? I have turned this one upside. Okay, removed here. Again I connected here. Like this, I can able to do more, right? So 1, 2, 3, again 4 here. Okay. Now see here. Can I able to do like this? This is also one. Okay, no problem. This is also one. No problem. I have turned this one. I can take one more. 1, 2, again 3, again 4. Yes or no? Correct. Correct. Okay. Now finally, see here everyone. Finally, see here everyone. Observe here. Can I do like this? Okay. Still it is a connected. Okay. Nothing but with this diagram. Okay. In this diagram. Okay. When you do this, can I able to get 4 possibilities? 4 possibilities are there here. 4 possibilities are there. Yes or no? 4 possibilities are there. With one simple diagram. With this one simple diagram. Yes or not? 4 possibilities are there. Like that. So this is okay. 4 we are getting here. I can check with this. One more. Is it possible like this also? One more thing. Is it possible like this also? See here. I will remove. I will start from here. 1, 2, again 3, again 4. So can I able to connect all the 1, 2, 3, 4? Everything is connected. Nothing but it's a spanning tree. It's a spanning tree. This is also connected everywhere. Spanning tree. This is also connected. Spanning tree. This is also connected. That's the reason why spanning tree. Can I write like this also? Please here observe here. Can I write like this also? 1 to 2. So you see the edges here. Okay, like this. Is it possible? See, is it possible? Like that. Rotate it. What it will become? It will become n. Rotate this one. It will become n. Yes or not? Like this. 1, 2, 3, again 4 here. So what I will going to do? I will going to rotate here. It will become like this. Yes or not? See? Correct? Okay. Again, one more. Is it possible or not? See here. One more. It is possible or not? See here. 1, 2, again 3, again 4. Okay. So 1, 2, 3, again 3 to 4. So minimum number of edges. Can I able to connect all? Yes or not? Yeah. This is also spanning tree. So like this, vice versa, you can take it. So 1, 2, 3, again 4. Yes or not? Again 4. So this is also possible. See, this is also possible. Nothing but what? Here also 4 possible. Here also 4 possible. Nothing but totally, okay, 8 spanning trees we are getting. 8 spanning trees we are getting. Totally we are getting 8 spanning trees. Yes or no? Totally we are getting 8 spanning trees. Okay, but see one more thing. Observe here. 1, I will say 1, 2, 3, again 4 here. Okay, now is it possible? Okay, this one, is it possible? Check it. 1 to 4 it is there. No, it is not possible. Be careful. That's it. It's not a spanning tree. Clear? This is all about spanning tree. So they will going to give you the graph. Using this graph, how many spanning trees are possible? You have to check it. That's it. Very simple one and easy one. Okay. So if you have any doubts related to this one, you can ask it. Observe this diagram. This diagram you see. 1 to 2, okay, no problem. 1 to 2, okay. So 1 to 3, no problem. But 1 to 4, is there any edge? No edge. This edge is not available. That's fine. It is not a spanning tree. It is not a spanning tree. Okay, please observe the given graph carefully. This is the graph. G is equal to V comma I. So this graph is very important. Be careful with this graph. Okay, now fine. So I think everybody got this one. This is all about spanning tree. Example 2, we will going to see one more. Okay, I will. Fine. So this is all about